Okay, we're in section 11.3, which is integral test and estimation of sums. This is example 1 part C that we're on. We got the series of 1 over n times the quantity ln n squared. Notice the little thing different here is we got n equals 2 for the start of the series. We just determined that if something's a p-series, that's a really easy problem. So maybe we want to look at that and check it out, but it's not a p-series, so that actually didn't work. Integral test, potentially. That's in this section. So if we want to explore the integral test, maybe you'd want to just even do the integral, but technically, kind of doing what we're supposed to do first. We're supposed to see if f of x is continuous, positive, and decreasing. So going in order here, my f of x is just replacing n with x, and we're looking specifically for x greater or equal to 2 because that's our starting point here. And just notice that we don't have any division by 0 here for x greater or equal to 2. ln x at 0 is not defined, so that's not true in general, but for x greater or equal to 2, there's no problems here. Also, it's positive, which for positive x and positive x, ln x for x greater or equal to 2 is positive, and then we square it, and nothing, no issues there. F of x is decreasing. Notice both x and ln x squared are increasing functions, and if we divide by something 1 over something that's always increasing, we're going to get something that's always decreasing. So didn't show that or anything, but and for the purposes of using the integral test, you wouldn't necessarily have to show each of these things, just sort of giving some verification that you check these things is good enough. But like I said, writing it down is important, and actually checking, because if these things do not apply, you cannot use the integral test, and it would be incorrect to do so. So anyway, after we got all that preliminary stuff, can we do this integral? And that, like I said, that's actually probably where you want to look at first. But I'm just going in order here. So we can use this integral test. Let's apply the integration symbols here. So the 2 is being used here because we're actually starting the sum at 2, so the formula sheet has a 1 there, so you just have to be a little bit careful. And we're taking a look at, can we do this integral? So it's a little bit in disguise here. It might not be obvious, but it is an integral we can do. I'm going to write it out with limit notation. Limit as t goes to infinity, and we're going to have the integral from 2 to t, and I'm going to write this a little bit different as 1 over x times ln x to negative 2, and if you didn't see it before, hopefully you see it here, that this is just a easy u sub. With my u equal to ln x, my du is 1 over x dx. So doing that, carrying along my limit notation too, what we're going to have is integral of u to the negative 2 du. So that really reduced to something pretty easy. Now I'm going to do my integral, so I'm going to add 1 to the exponent, I get negative 1, throw that negative out front, and now we get to start, well actually I'm going to go back in terms of t. So it's negative, and then it's 1 over, sorry I'm just trying to do too much at once here, or another step, so negative ln x, and that's to the negative 1, go back 2 and t. Okay, now plugging in, so we have limit as t goes to infinity of negative 1 over ln t minus a negative, so plus overall 1 over 2. Okay. So as t goes to infinity, ln t also goes to infinity. So overall we have this thing, first term, going to 0. So 0 plus 1/2. Wait, I screwed up here somewhere. Let me backtrack. Oh, let me backtrack. So it was not, I was looking at the u there for a minute, but this is actually ln of 2. Alright, so going back. Everything looks good. 1 over ln 2 is a constant still. So 1 over ln 2 for that limit, and it just ends up being 1 over ln 2. So what we were just doing here was an integral, and so we were going back to 7/8, but this is not the value of the series. I have to be a little bit careful here. What we determine is that the integral is convergent, and by the integral test, what we get here is that our series from n equals 2 to infinity of 1 over n times ln n squared also converges. By the integral test, which I wrote right there, so I'm not going to rewrite it. So, in general, our series is not equal to 1 over ln 2. That is exactly what that integral was, but you could use an estimate. You know, they're close enough that you could use it as estimation, but we're going to learn better techniques than that. So going back to that picture, you could use this integral, which would be the area under the red curve, as an estimation for what we have here with the tan bars, but you can see it's kind of a off representation. So again, in this section we're skipping the remainder part, which has to do with the error of using the integral as an approximation. Like I said, it doesn't end up being an awesome estimate, so we're gonna just move on at this point. That's it for this section.